It's that new time of year, 2024, and we have a new advent of code. I will be straightforward and just say that I've already attempted to record this video and I failed, and so now we don't get to do this together, as if I was just figuring it out from the beginning. But maybe tomorrow it'll be a better day. So whatever, we'll do day one together. I already know the answer, but it's not really a big deal. It's not that hard. And we'll be doing it in Rust, as I usually do. So yeah, let's get started. Started something. It's just going to be a mono repo. So we're just going to create the new lib for day one. There we go. That doesn't need to be there. Okay, so we have the day one historian of Hysteria, which is the first challenge. I always do enjoy just copying the whole prompt, just so I have this. There we go. Great. We're gonna make our solve function, which is just gonna take the raw input string, raw input, and we're gonna return a U64, which sounds pretty good. Let's get down to business, all right? So the little elves, there's two teams of little elves, okay? Essentially what I've understood. One is they're gonna make two lists. There's the left column list right here on the left side, and there's a right column list. And these lists are supposed to somewhat match, but they don't. So there's a problem. We have to solve it together, okay? The problem is that the smallest number in the left list you have to find it in the right part of the list. So for example, then you can see one's the smallest in the left list, and 3, for example, is the smallest in the right list. There's multiple 3s, but we don't really care about that. So what's next? Once you find the two smallest numbers, you find the difference, the absolute value difference between the two. So for example, if it was 1 and 3, then that would be the value of 2. And then once you get all the differences as you go through the smallest numbers to the highest numbers, then you just add all the remainders together, or the differences, and you're supposed to find, I think it was 11 for this value right here. Okay, so that's exactly what we're going to do. So I'm just going to copy the input. I've already renamed this to solve because I already know what's going to happen, and we're going to create the input, which is just going to be a multi-line string. Let's kind of like clean that up a little bit. There we go. That looks pretty good. So it's a multi-line string. We're going to call solve with this string with inputs. There we go. And it's supposed to equal 11, as we saw in the example. So here we get the input. So we can tell that, first thing we can tell is that the input string, there's about 1, 2, 3 spaces in between the numbers. So it's kind of evenly spaced, and it's by line. So what we want is we want to make two lists. Let's call it list 1, which is going to be just a vec, and a list 2, which is also going to be a vec. And we can say that it's going to be a vector of U64 values. U64. Why do I choose U64? I don't really know. It's maybe because the puzzle, if you look at your own little puzzle, this is my puzzle input. You can see the values get pretty big. Not that big though. I think a U32 would probably be fine. But we have to add them together, so let's just leave it as is for now. We can always optimize it later. Right. So we have the raw inputs, and we're just going to go for like the naive kind of solution at the beginning. We can optimize the algorithm later. So first we just need to kind of organize it into the different lists. So what we can do is we can loop through, let's say, every line. We can take a raw input, make sure we trim it. We split it at the backslash n. I think that's pretty good. So now we have a line. Now for each line, we're going to want to get the part 1 and the part 2 for each list. Oops. Right, for each list. And now you can do with just a line dot, you want to trim the line, you want to split at, and you want to do 3 spaces. Right, so now we have the 2 parts. Let's just, for testing purposes, make sure we just return a value or something so it doesn't yell at us. Why isn't it happy with that? Oh, split. Sorry, it's split once. One split once at one area. There we go. What's it not happy about? It's an optional. Obviously, it's an optional. It's because it's not sure that we're going to be able to actually split it once at that value. But we are 100% sure because this stuff is normalized, so it's all good. So yeah, we have that. So then we just need to add the each element to each list. We do parse dot unwrap list 2 push part 2 dot parse. Oops. Okay, we'd have to make these mutable. There we go. And that's not bad. So now we have the lists, both lists with the values in them. And if we want to see what's actually in the list, let's go ahead and do that. We have to put that in debug mode, otherwise it's not going to work. List 1, list 2. Right, we can just run the test and see. It's going to fail, but here we have both lists. So what we need to do now is we need to take the smallest number and match it with the other list's smallest number. To do that, since the lists are the same length, we can just simply order the lists at the end. Just a quick sort, list2.sort, and that should be good enough to sort them. So we can actually match them much easier. And as you can see, they are now well sorted, which is good. Right. Next, we simply need to do the matchings, and we can just use the name of what they called. It was part 2. What is the total distance? So we'll call it total distance. I'll call it total distance, which is by default 0. And it's going to be mutable. And so what we're going to be doing is we want to loop for e in 0 to the list 1.length. They both have the same length. It doesn't really matter which list you use. But yeah, we're going to do value 1 from list 1 e. We're going to do let value 2. In fact, we could just simplify this. We don't actually need to do that. We'll do total distance plus equals. We'll do list 1 of e, and there's a little nice little called ABS diff, which is exactly what we want. List 2 of e. There we go. Nice. That's exactly what we want, and then we can just return. We can just return the total distance like that. So that should just work if I'm not mistaken. Yeah, it works. It's passed. So now we can actually try the actual puzzle that was provided with us a little bit earlier. All right. We're gonna copy all that. And we're gonna put it here. I'm gonna put puzzle, puzzle.txt. Nice. We have the puzzle, which is 1,000 puzzles, 1,000 lines of the lists. It's not too bad actually. And we're gonna make another test. it works with the puzzle. And the input just going to be fs read to string, and it's just going to be puzzle.txt. We can just check to see real quick if that input actually works. It's going to be unwrap, and we simply check to see if that actually outputs, and we have the output, which is what we wanted, so that works. Right, then we can just copy this thing and see if that works. So this is a string. I can just do as string. That's gonna be fine. We can simply see what happens next. And we find this value, which I can confirm, since I've done this already, that is the right value for day one, part one of the puzzle. Right, so that was part one, right? So we just name this part one, rs, we can move all that to part one. We can do mod part one, and we're also going to do part two. All right, so part two is essentially not that much different. What needs to be done, if you look at the requirements. So part two, essentially what happens is you want to actually find a similarity score. So for example, if there's 3, well, you want to count how many times 3 exists in the list on the right. It exists 3 times. So you take the number of occurrences times the original value. So 3 times 3 is 9. 4, for example, exists only once. So it's just 4 times 1. Okay? And if it doesn't exist at all, it's just times 0. So you actually don't count it. And then you add all those values up and you get the final results. That's all that is. So the first part is fine. You don't need to sort anymore. And you don't actually need to find the total distance. You need to find the similarity score. All right. And for this, we just need to loop through both lists as we did before. Actually, no, we need to make to do that, we need to have a map, a hash map, where we actually count the occurrences. Oops, excuse me. There we go. Now we should, those are the occurrences. So yeah, so now we need to go for value in list 2. So we want to find the occurrences in list 2. We can do if some occurrence equals map dot get mute. You want to get the mutable reference of whatever's in the hash map to be able to change it later. So as you can see in the example here, you want get mute, and then you want to change it within this bracket right here if it exists. If it doesn't exist, then you can just simply add it. So yeah, and the value we want to pass is obviously value, and we can do occurrence equals plus equals 1. So for example, if we already have an occurrence of 1 and we simply want to do it again, we just simply want to increase the number of count for that value. So it's telling me it's not very happy with what I did here. It's maybe because I forgot to let. There we go. And if we don't find anything, then we're simply gonna add it to the hash map. So here we can do map.insert, which will be the value, and obviously the default occurrence is gonna be 1 the second we see it. There we go. So now we have a hash map of all those values, which is really good. Then we can actually loop through list 1, which we can just call this value. We don't actually have to enumerate or whatever. We can just do for value in list 1, which is good. And for each value in list 1, we're going to do similarity score plus equals. Here we're going to take the value times map.get the value and or 0. I don't know if that works, but if it does work, it'll be sick. So this needs to be that, like that. Yeah, so it says it's optional for now, so it's not exactly or. It needs to be yeah, I think it's unwrap or. I think that's better. I don't think I need these parentheses. Yeah, we can just do that. There we go. So what we're doing here is we're taking the value, we're timesing it times whatever we found in the map. So the number of occurrences. And if there's no entry, we simply pass 0. So it'd be like value times 0 if it doesn't exist. So that should provide us with the value we're looking for. And what do we find? And that is indeed the value we're looking for. So that is it for day 1. Thank you for watching, and stick around for day 2 tomorrow. It's pretty easy. It was a bit fast as well, obviously, because I did it right before and I had to do a lot of reading. It took a little bit longer, so. But yeah, it wasn't too hard. I think the next question would be like, obviously because it's easy, it's, you know, it's like, how can you improve it? Like obviously this is a linear complexity. There are no nested loops at all. And I'm pretty sure you would be able to actually make this more optimized. For example, just when you're parsing everything, while you're parsing, you can also maybe sort at the same time. I think it would probably work as well instead of doing the sorting afterwards. So it would save some complexity. But I think this is unavoidable in general. But yeah, I don't think it gets much more complicated than that. This one, I don't think there's much more you can do to make it better. So, I mean, sometimes it's questionable to see if even a hash map is useful, because the lookup time might take longer than just having a list of values. I think I read that somewhere. So I don't know, might be worth checking, but I think this is already pretty good enough. Thank you.